This video is brought to you by mywayteaching.com.
In this part, let us learn equation of path of projectile. So we already learned these two equations in case of projectile motion, isn't it? So what is the shape of the path that is followed by projectile? Yes, that we can see by eliminating the time between the expressions for x and y. Okay, if you eliminate the the time between the expressions x and y, we can get the path of the projectile. Okay, so we can represent y is equal to tan theta naught into x minus g by 2 v naught cos theta naught whole square into x square. Okay, if I write or we can write it in other words as hm is equal to v naught sine theta naught whole square by 2g. Okay, so now g theta naught and v naught are constants. So this equation is of the form y is equal to ax plus bx square, in which a and b are constants. So and this is y is equal to ax plus bx square is the equation of parabola, isn't it? So the path of the projectile is also parabola. So that is the end result. Here we, from this first x coordinate value, we have taken the value of t, and that value of t we have substituted in this y. So when we substitute the value of t, that is t is equal to what? X by v naught cos theta naught. In y, the t, the in place of t in the second equation, we'll get this equation. So the path of a projectile is parabola. You can see the path here. The path is nothing but parabola, isn't it? Now let us find the time of maximum height, which means how much time does the projectile take to reach the maximum height. So let this time is denoted by Tm. Okay. Since at this point, means at the point of maximum height, we already know Vy is 0, isn't it? So we can consider the equation Vy is equal to V naught sine theta minus G. In case of t, we will write it as Tm. Okay, so since Vy is 0, we'll equate it to 0, and maximum height, we'll get it as V naught sine theta naught by G. Okay, the total time Tf during which the projectile is in flight can be obtained by putting y is equal to 0 in the equation, that is y is equal to v naught sine theta naught into t. In case of t, we'll consider it as tm, and half g tm square. Okay, and So we will get the total time TF is given by 2 into V naught sine theta naught by G. Okay, the total time. So when we throw a projectile, it will reach the maximum height. Again, it will come back, isn't it? So that total time is given by 2 into V naught sine theta naught by G. Okay. So what will be the expression for maximum height of a projectile? So the maximum height is represented with HM and it is reached by the projectile, okay, by substitute, okay, it HM is the maximum height that is reached by the projectile and it can be obtained by substituting T is equal to Tm in the equation, that is y is equal to V naught sine theta in the same expression, that is y is equal to, we already know, that is V naught sine theta minus half gt square. Okay, so we should find the maximum height, s- that is given by hm is equal to, so here it is given by V naught sine theta into V naught sine theta naught by G. Okay, the time taken by the projectile. So that we have to substitute in place of G. If you simplify this, we get Vm is equal to V naught sine theta naught whole square divided by 2G. Okay, this is the expression for maximum height of a projectile. So now range of a projectile, the horizontal distance traveled by the projectile is nothing but the distance from its initial position to the position where it passes y is equal to 0 during its fall. So we can find the horizontal position by r is equal to v naught cos theta naught into TF. So we already know the expression for total time, that is nothing but 2 V naught sine theta naught by G. So the horizontal range is given by V naught square sine 2 theta naught by G. So it shows that for a given projection velocity V naught, R is maximum when theta naught, that is sine 2 theta naught is maximum, and when theta naught is 45 degree. So the maximum horizontal range is given by V naught square by G, isn't it? Yes. So now let us solve a simple problems on this. The first problem, Galileo in his book Two New Sciences, okay, stated that for elevations which exceed or fall short of 45 degree by equal amounts, the ranges are equal. Prove this statement. See, for a projectile launched with velocity v naught at an angle theta naught, the range is given by r is equal to v naught square sine 2 theta naught by g, isn't it? We already proved this. So now for angles, that is 45 degree plus alpha, and even for 45 degree minus alpha, this 2 theta naught becomes how much? 90 degree plus 2 alpha and 90 degree minus 2 alpha respectively. The values of sine 90 degree plus 2 alpha and sine minus 90 degree sine 90 degree minus 2 alpha are same. Therefore, the ranges are equal for elevations which exceed or fall short of 45 degree by equal amounts alpha. Okay, the value for sine 90 degree plus 2 alpha is the same as that of sine 90 degree minus 2 alpha. So we can easily prove this statement, isn't it? So the next problem is a hiker stands on the edge of a cliff 490 meters above the ground and throws a stone horizontally with an initial speed of 15 meters per second. Neglecting air resistance, find the time taken by the stone to reach the ground and the speed with which it hits the ground. So we choose the origin of the x and y axis at the edge of the cliff and t is equal to 0 seconds at the instant the stone is thrown, isn't it? So choose the positive direction of x-axis to be along the initial velocity and the positive direction of y-axis to be vertically downward direction. So the x and y components of the motion can be treated independently. So we already know the x and y components, isn't it? So x of t is nothing but x naught plus v naught of x into t, and y of t is nothing but y naught plus v naught of y into t plus half ay into t square. So we know x naught is equal to y naught is equal to, in this particular case, the initially x naught and y naught is 0 and voy is 0 and ay is minus g, that is minus 9.8 meter per second square, and v naught x is given as 15 meter per second. Okay, the stone hits the ground when y of t is minus 490 meter. So we should substitute y of t as 4 minus 490 meter, and substituting all the values we get it as half 9.8 into t square. So this gives the value of t as 10 seconds. Okay. So the velocity components are Vx is equal to V naught x and Vy is equal to V naught y minus gt. Okay. So that when the stone hits the ground, V naught x is 15 meter per second and V naught y is given by minus 98 meter per second. So the speed of the stone, if you calculate the speed of the stone, is given by square root of vx square plus vy square. So we know vx, we know vy. So if you find out this square root, we get it as 99 meter per second. Okay. Neglecting air resistance. What does this assumption really mean? Yes, while treating the topic of projectile motion, we have stated that we assume that the air resistance has no effect on the motion of the projectile, isn't it? Friction, force due to viscosity, air resistance are all dissipative forces. In the presence of any of such forces opposing motion, any object will lose some part of its initial energy and consequently momentum too. So, thus, a projectile that traverses a parabolic path would certainly show deviation from its idealized trajectory in the presence of air resistance. So it will not hit the ground with the same speed with which it was projected from it. In the absence of air resistance, the x component of the velocity remains constant and it is only the y component that undergoes a continuous change. However, in the presence of air resistance, both of these would get affected. Okay, that would mean that the range would be less than that we found out just now. That is, the range we got the value of range r is equal to v naught square sine 2 theta naught by g, isn't it? It will be less than that. Okay, and even the maximum height will be less than the predicted one. So in order to avoid air resistance, we will have to perform the experiment in vacuum or under low pressure, which is really not easy. So when we use a phrase like neglect air resistance, we imply that the change in parameters such as range, height, etc. is much smaller than their values without air resistance. Okay, calculation is very simple if you consider air resistance is negligible. Okay, so now let us solve another simple problem. A cricket ball is thrown at a speed of 28 meter per second in a direction 30 degree above the horizontal. So calculate the maximum height, the time taken by the ball to return to the same level, and the distance from the thrower to the point where the ball returns to the same level. So the first one, the maximum height is given by hm is equal to, okay, here they have given the velocity v naught as 28. So the angle theta naught is 30 degree and the value of g is 9.8. Okay, so if you simplify this, we'll get the maximum height as 10 meters. In the second case, the time taken to return to the same level, that is the total time TF, is given by 2 V naught sine theta naught by G. Okay, so the total time we get it as 2.9 seconds. The third case, that is the horizontal range, is given by v naught square sine 2 theta naught by g. So it is, if you simplify this, we get it as 69 meters.